Alright, so this is just practicing the tree conditional cases where we've thrown in the new problem. So it's a mixture of the 7-6 part 2 tree cases with the new conditional case in 7-6 using Bayes' theorem. Alright, so we're just going to practice that in this set. So this should be the last video, and we're just going to go through a handful of examples. Alright, so the first one. The probability the person with certain symptoms has hepatitis is 0.8. So that means they have symptoms, they go to the doctor recognizes these symptoms, that there's a high probability they have hepatitis. Now, not everybody with the symptoms have hepatitis, but there's a 0.8 or 80% chance that with these particular symptoms they have it, which means there's also a 20% chance they don't. So they do a test. Right? With every test, there's always the odds that the test comes out wrong. Now, testing is getting better, but there is always false positives and false negatives. That's why you usually test things more than once. Right? You usually do more than one blood test, more than one test. Alright, so this particular hepatitis test, the blood test used to confirm the diagnosis, has a positive results, meaning saying they have hepatitis, for 90% of those who do. Right? So that's a condition. Given they have the disease, so those that have the disease, the test results gets it right 90% of the time, meaning they get the positive, yes they have it, given that they actually had it. 90% means it gets it wrong 10% of the time. 5% of those without the disease. Alright, and so again, it's a little weird the way this is worded, and so it's still giving positive test results, and it's giving positive test results, to 5% of those without the disease. So 5% of the people who are tested are getting positive results, even though they're from the 20% that don't actually have it. Right? It's a false positive. And so we'll use that to set up my tree. Right, and the question. So I'm going to do the question. Actually, this one I'm going to do the question first, then set up the tree. But those are my conditionals, right? Whenever you're testing anything, right, we did a test results in 7-6. If you go back and look, we did the drug testing cases for athletes. And this is a testing for a particular disease. Whenever it's a testing example, it's always a tree case. Because the test results are dependent on whether they have it or they don't, right? They're using the drugs or they're not, they have hepatitis or they don't, right? It's conditional. The probability we're looking at is the probability that an individual with certain symptoms who reacts positively to the test actually has hepatitis. So we're not looking at everybody with symptoms. We're not looking at 100% of the people with symptoms. We're only looking at those who got positive test results, right? Those who the test results reacted as positive. We want to know, well, if I've got a positive test result in my hand, what's the odds that I actually have it, right? Because that's what I want to know. What's the chance that the test results are correct? And so this is a conditional probability, and this is an end result, right? The end result is I have the positive test results. I want to know if I have the positive test results, I came from the 80% group that actually have it. Alright, so this is a conditional. Right, probability they have hepatitis, given the test results were positive. Positive meaning they have it. Alright, and so I'll have to fill out the formula, the probability that they got positive test results. That's the given, right? I know I've got positive test results. So I divide by, we have the test results were positive. Up top is the conditional, or not the conditional, the and statement. They have hep, and they got test results that were positive. Right, not everybody, most of the people who have positive test results have hepatitis, and we'll see what that most percent is. But there is a small percentage, right, based on that error here, this 5% error, that if you have test results that were positive, you don't actually have it. But it's not 5% of everybody. It's only 5% of the 20%. And so I have to set up my tree to figure this out because it's based on conditionals. All right, now I only need to figure out the positive test results. I don't have to worry about, and there's nothing in here about the negative test results. So when I set up my tree, I'm only going to do the positive case. I'm not going to do the negative case because I don't need it. All right, I only need the positive test results. All right, so now my tree that will help me organize my information so that I make sure that I fill out this formula correctly. Alright, so my tree. So first is it's those with symptoms. Right? They have symptoms, they go to the doctor, there's odds that they have it, the odds that they don't. They take tests, alright, they take a test. And then all outcomes. And again, I'm not going to actually find all the outcomes. I'm just going to do the positive test result ones. Alright, so if you have symptoms, you go to the doctor. The doctor recognizes, well, there's a chance that you have hepatitis. There's two things that can happen if you have symptoms. Either your symptoms, you have whatever disease it is, or you don't, right? Alright, so these have hepatitis. These do not have hepatitis. Alright, you have test results, so the test comes out positive or negative. Test comes out positive or negative. Alright, you can use P and N for positive and negative. I just had to write it out. All I want is the positive cases, right? This was the end result probability here that I'm looking for is they have hepatitis and it came out positive. This is they do not have hepatitis. So I'm going to do H prime. Not hepatitis. But they still got positive test results. Right, and that's it. Those are the only two outcomes. I don't need the negative cases, so I'm not going to write the negative cases out. I'm just going to do the positive cases because that's all I need, because that's my given. Given they got a positive test result. Alright, now I fill out my tree. Alright, the probability, if they have certain symptoms, the probability they're in the group with hepatitis, well, that was 0.8. So there's an 80% chance they actually have it. There's also a 20% chance they don't. Right, they have these particular symptoms, and for whatever reason, they have these symptoms, but it's something else. It's not hepatitis. Right? That happens a lot with illnesses. But either way, they give them a test, right? They test to see if they actually have this particular disease, hepatitis. All right, so if they have hepatitis, so given they have the disease, right? Those who have the disease, they get positive results 90% of the time. So 90% of those who have it will get positive test results. So that 90% goes here. Given they have hepatitis, the test result will come out positive 90% of the time. So 0.9. Negative would be 0.1. I don't need it, so I'm going to leave it off. Right, the second set of branches is the second piece of information. They get positive test results. 5% of those who don't have the disease. So they're part of the group that doesn't have the disease. 5% of those without hepatitis still get positive test results. And so that's the set of branches. Given they don't have the disease, 5% of the testing of those tested who don't have it will get positive test results. So it's 5% of the 20%. So this is 0.05. Make sure you write 5%, not 50%. And then you multiply out and figure out, well, what's the chance of getting each of those outcomes. Alright, so the first one is you have it, you're part of the 80% that have it. You were tested, the test catches 90% of those who have it. So it's the 80% times the 90% it catches, and so we multiply that out. And so 0.72. And what that means is 72% of the 80% got positive test results and they actually have it. Which means there's 8% who got negative results, although they have it. Didn't need to know that, but that's just an FYI. Alright, then the second part of the tree that I'm going to figure out is, out of the 20% that don't have it, 5% of those people will get positive test results. So it's 5% of the 20% who don't have it. And so we take our 20% times our 5%, and that comes out to 0.01. So 1% of the people tested fall into the group where they don't have it, but they got positive test results. Alright, so these are all of the people with positive test results. So the probability the test came out positive is these two outcomes, right? Positive test results. So I add those that have it plus those that don't. So 73% of those people tested have positive test results. 72 actually have it, 1% don't have it. Alright, but that's what I need. So there's all the numbers I need to answer my question. But now I have to go fill out the formula, right? The conditional Bayes formula. So there's all the numbers that I need for my formula. So I go back up here to my formula and I fill in the missing pieces. Alright, so I'm kind of done with the tree except for just pulling information out. Alright, so positive test results was this 73, right? I added up these two cases and it came out to the 73. So 73% of those people have positive test results. Out of the 73, well, what's the chance they actually have hepatitis? Well, that's this 0.72. Out of the 73 people, 73%, that got positive results, 72% of those actually have it, right? 1% didn't. So I put my 7-2, because those are the people I'm looking at. They have hepatitis and they tested positive. That's this group. And so there's the formula. There's the Bayes conditional formula. And then you take your 0.72 divided by your 0.23. And that answers your question. All right, I'm going to round about 3 decimal places. So 0.986. So the probability, if you've got positive hepatitis, if you had these certain symptoms, you went to the doctor and you were tested. When you got your test results back from the doctor, you have the test results sitting in your hand. Well, the probability that the test results, that you got the positive test results, the probability that you actually have it, based on our statistical numbers, is a 98.6% chance. And there's a pretty good chance that you have it if you tested positive. Means it gets it wrong 1.4% of the time, right? 1.4% of the people who got positive test results don't actually have it. Out of everybody who's tested, all right, it does get it wrong about 1.4 based on these numbers. All right, so again, there's that example. Let's get on to the next example. All right, so this is kind of another testing. It's testing lie detector test. All right, this is actually one, they like the lie detector test on the final exam. This is actually one I pulled from a final exam. All right, suppose we have a lie detector test that has a probability of 0.1 of saying someone has lied if he or she really told the truth. All right, so that's a conditional. They've been tested, and it gives it out a 10% chance they said they lied, but they were really people who told the truth. All right, so that's a conditional probability. It has a probability of 0.2 of saying when someone has told the truth if he or she really lied. And so these are kind of worded weird. You have to be careful and kind of read it. And I actually suggest reading it out loud. I think it's a little easier. And if you're on a test or quiz, it's fine if you read it out loud. It's easier to understand it if you hear it as well as read it. Again, it's just a little easier. I actually think it's easier to do that. And so these are a little tricky. So the first one is they were telling the truth, but the lie detector said they lied. All right, so given they were telling the truth, the probability that the lie detector said they were lying was 0.1. The second one is given they lied, right, the probability the lie detector said they told the truth was 0.2. So it's giving you the falses, right, false cases. A lie detector test was administered to a large group of people. A question will be asked that 40% of the population is known to lie about. All right, and then we're going to do a tree, and then we're going to answer 2 questions based on the tree. All right, so I set my tree first. All right, so first of all is we ask the question that people are known to lie about 40% of the time. All right, so we have a question. All right, and then we're testing them, and then all outcomes. All right, you always have to do whatever you're doing first, and then the test is always second. Same thing with the hepatitis test, second, the results are second. Lie detector test, the results are second. All right, so we ask a question. Either they lie, or people tell the truth. All right, there's a probability they lie, the probability they choose, and then they're tested. All right, so the test results. So this, I'm going to write TL represent test said they lied. TT represents test said they told the truth. All right, so test said they lied. Test said they told the truth. Right, and then all my outcomes. All right, so probability they lie, and the test said they lied. Probability they lie. Test said they didn't, though. They said they told the truth. Probability they told the truth. I'm not using my R backwards here, apparently. But the test said they were liars. And the probability they told the truth. But the test said they told the truth. Alright, and there's all my outcomes, right? You answer a question, either you're going to lie about it, or you're going to tell the truth. And the outcomes for the test results are either it said you were a liar, or it said you were told the truth, and again, depending on which way it went, there's odds that it got it right, and there's odds that it got it wrong. Right, based on the numbers. Alright, so filling out the tree. Alright, so the first one is the question, right? The question that we're asking that 40% of the population we know lie about. So 0.4 is the odds they're lying, which means 0.6 is the odds they're telling the truth. Alright, then these are conditionals. based on what group they were in, there's the odds the test results came out correct. Alright, so the first one was telling me the test has a probability of 0.1 of saying someone has lied if they really told the truth. So in the first probability, we're in the told the truth group. So we're here, we're on this branch. They're in the 60% who told the truth. So given they told the truth, the odds that it got it wrong, the test came out that they lied, right? This is the lie path, was 0.1. And that's the hard part about this one. It's just weird the way it's worded. So I think this one is actually a little easier. Like I said, if you say it out loud, it's a little easier to understand what they're saying. Alright, then the second one is they have a probability of 0.2 of saying someone has told the truth if he or she really told a lie. And so we're in the lie group, right? We're in the 40% who lied. They're on this branch, though, because they're lying, but the test is coming out that they told the truth. And so the test gets it wrong if they were lying 0.2, 20% of the time. 20% of the time, if they're in the lying group, the test will come out that they're not lying, that they're telling truth. So 0.2. All right, then I finish my tree. All right, these should add up to 1, so it gets it right here 80% of the time. It gets it right here 90% of the time. And then my end result, so I multiply down. So what's the probability they lied and were caught? Right, that's the first one. Probably they lied. Test said they lied. Well, 0.4 times 0.8 is 32. All right, so 32% of those people lied, and the test said they lied. So remember, it's the 32% of those 40. All right, so out of all the liars, 32% of them were caught, which means 8% were not. Right? And if you multiply this out, you take your 0.4 times your 0.2. That's what comes out. 0.8. There's all of the liars. Right? There's 40% of the people who lied. 32% were caught. 8% got away with it. Test came out wrong. Right? So this would be the wrong case. All right, the second set of branches would be they're in the 60% who are truth tellers. Right, they get it wrong 1% of the time, so the probability they told the truth, but the test said that they didn't. Well, that is 0.06. All right, so it gets it wrong 6% of the time. All right, these 6% were truth tellers, but the test said they weren't. All right, and then the last one would be 0.6 times 0.9, which comes out 0.54. All right, so that's 54% of the group were telling the truth, and the test said they told the truth, right? This is the 54% of the 60, where the test got it right. Right? And there's all the possible things that can happen on this particular lie test, detector test. Right? There's all my outcomes. So there's my tree, and then the 2 questions based on the tree. Right, find the probability the person lies and is caught by the machine. Right, so probability that a person means out of all of the people who were asked the question, right? A person means anyone could be selected. So if they were any of my people, what's the chance they were liars and the machine said they were liars? All right, so we're looking for the probability they lie and the test said they were liars. Well, that's all of my outcomes, one of my outcomes. That's this outcome up here, 0.32. All right, so 0.32. 32% of those people who were, all my people, 32% of them were liars, and the test said they were liars. Right, the second part of this question. The test indicated a person was lying. Find the probability that he or she was actually telling. So this is the worst case scenario, right? This isn't the worst case scenario. Sorry, this is the other case scenario. The worst case scenario would be that it came out that they. Oh no, this is the worst case. That's what I was thinking. Get it right, Stephanie. All right. So test indicated a person was lying. What's the probability they're actually telling the truth? All right. So they got it wrong, right? The test results were wrong. And that's what I have. It's the end result of the tree, right? I'm given the test results. What's the probability they were part of the 60% group that were telling the truth? All right, so this is the new case, right? The Bayes formula 7-6 case. So probability, they were telling the truth. They were part of the truth group. Given, though, the test said they were liars. All right, so the formula is, up top is the probability they were the truth. And the test said they were liars. Over the given outcome, which they were liars, right? The test results. So again, what you have in front of you is the test results. All right. So out of all of the test results with the liars, what's the odds that they were actually from the 60% of the group that were telling the truth? Alright, so this is the case where I'm looking at all the outcomes, the tree into the tree. Alright, so I have to figure out, well, out of all the outcomes where they were lying, and so I need the lying outcomes. Alright, so lied and they were lying. Lied, oops, test said they were lied, and they were telling the truth. Alright, so these are the two outcomes I want, right? This is the test results came out that they were liars, right? Those are all of the test results that came out there. So 0.32 where they were lying, 0.06 where they weren't lying, right? And so that's the bottom part. Right, I take my 0.32 plus my 0.06. Up top is the case that they were truth tellers, but the set tested it. So that's the 0.06 case. So that goes up top here. Alright, and I'm going to add up the bottom before I do my division. So the up top is the outcome where they were truth tellers, but the test came out that they were lying. The bottom is everybody who got test results that were lying, right, which would be the 0.32 and the 0.06. So out of everybody, 38% of the people got test results that they were lying. Right, that's out of everybody. 38% got lying test results. 0.06 of them, though, were from the group that were telling the truth. And so we do this division. You take 0.06, divide by your 0.38, and it comes out to 0.1875. Alright, so if I have test results that are positive, or that are not positive, if my lie detector says they're lying, I actually have almost a 19% chance that they're telling the truth. So this isn't a very good lie detector test, alright? I wouldn't really go by it. That's actually a pretty high chance that they get it wrong. And in the bad way, right? They get it wrong in the bad way, where they said they're liars when they're actually telling the truth. Right? And so that's the odds. The odds that if I have somebody's test results saying they're lying, there's actually an 18.75% chance that they were really in the group that told the truth. Alright, I believe this is the last example. Alright, so we have a business that offers degrees in management, finance, and accounting. 50% of the recent graduates were management majors, 30% were finance, the remaining were accounting. A survey of recent graduates, so we surveyed graduates, found that 65% of the management had a job in their field of study, 60% of the finance had a job in their field of study, and 85% of the accounting. And so those, I'm highlighting those because those are important to recognize, because that's what you're going to do on a quiz. Recognize, what case is this? This is a conditional tree case because I'm giving you conditional probabilities, right? 65% of the management majors are working at a job in the field of study, meaning not all of the people, it's just the management. That's a conditional. Given their management majors, this is the odds they're working in a field in their management field. All right, and 60% of the finance, so given their finance, 60% of the finance majors are working in their finance field, and 85% of the accounting majors are working in accounting. All right, so first is their degree. Alright, so the graduate degree. Alright, then the job in that degree. All outcomes. Alright, so there's 3 degrees. There's management, finance, and accounting. So I'm going to do MFA. So M for management, F for finance, A for accounting. And then I'm going to do J for a job in their field of study, or J prime, they're not working a job in their field of study. Alright, so J means they are, J prime means they're not. Alright, so J prime. And then all outcomes. Alright, so these are the probability of their management, and they have a job in management. These are the probability of their management and they're not a job in management. Probability finance with a job in finance. Probability of their finance, not a job in finance. Probability of their accounting with a job in accounting. Probability of their accounting and not a job in accounting. Right, and those are all my possibilities. Alright, graduate's degree. 50% of those graduated with management, so 0.5 are management. 30% are finance, so 0.3, and the rest are accounting, so 80%, so that means 20% are accounting. And there's all my degrees, right? 100% of my degrees, 50% management, 30% finance, which means 20% are left over for accounting. All right, now they're working a job in their field of study. So these are the conditionals. Given they're one of those degrees, the odds they're working a job in their field of study depends on which field it is, right? So 65% of the management majors are working, so given they're a managed major, 65% of those are working in a job in management. All right, so 65 goes here, which means 35% are not. All right, 60% of the finance, so given they're a finance major, 60% of them are working in a field in finance, which means 40% are not. And then accounting, 85%. So most of the accounting majors are working in their field. So 85% of the accounting majors are working in their field of study. 15% are not. And then the end results. All right, out of all the graduates, the odds that they're management and working a field in their study, why multiply 0.5 times 0.65? 0.325. 0.5 times 0.35. 0.175. So there's all my management majors, so that should add up to 50%. It does. If you add those up, that's 50%. All right, now the finance, 0.3 times 0.6 is 0.18. 0.3 times 0.4 is 0.12. And now, again, that's 30%. If you add that up, it's 30%. And then the 20% that are accounting, 0.2 times 0.85, 0.17, and 0.2 times 0.15, 0.03. And if you look at that, the 17 and the 3 added up to my 20% of my accounting major. Alright, so there's my tree, which again, we've now done about 20 of these, so you should be pretty good at that. So I went through that sort of fast, and hopefully you could follow along. Alright, now the questions based on my tree, which, like I said, this will be how it asks on a quiz. Alright, you'll ask you a question, you'll have to set up a tree, and then there'll be two or three of those based on the tree questions. Alright, the first one. What percent, percent this time, what percent of recent graduates were not working at a job in their field of study? So I need to write it as a percent when I get to so if this were a test question, a quiz question, I need to make sure at the end I write it as a percent. First I'm going to figure out, though, with the probability. So percent of recent graduates, so out of all of the graduates, right, all of them, so they can come from any major, what's the probability that if I have a recent graduate from this school, they are not working in their field they studied in? All right, so out of all, probability they're not working a job in their field of study. And so they could be any of my three majors, so I add up all the different outcomes, right? Probability they were management and not working a management job, plus the probability they were finance, not working a finance job, and probability they were accounting and not an accounting job. All right, so I go add up all of those outcomes. So 0.175 for management, 0.12 for finance, and 0.03 for accounting. All right, add them up. So 0.325, which is not your answer. Right? If this were a quiz and it said percent, you don't give 0.325. You want to make sure you convert this to a percent, and your answer would be 32.5%. Right? 32.5% of the graduates from this university are not working in whatever degree they graduated in. Right? So 32.5%. Right, the last question. If a recent graduate responded they were working in a job in their field of study, find the probability those graduates were accounting majors. Right, so again, conditions. I'm not looking at everybody. I'm only looking at those who are actually working at a job in whatever they studied in. Right, so they have a job in their field. Given they're working a job in their field of study, which is the end result, what's the odds that they were accounting majors? Right, so this is a conditional. All right, we want to know the chance they're accounting majors given they're working a job in their field of study. Right, so the formula, well, we divide by all of those people who are working, because again, that's what I know. Right? Out of all the people working at a job in their field of study, what's the probability they're accounting? So we divide by all of those who are in jobs in their field. Up top would be the accounting majors and the jobs. All right, well, there's two ways to do this. This is the complement to the event I have up here, and so you could just take 1 minus the 0.325 and get that this is 0.675, right? 32.5% are not working in their jobs field of study. 67.5 are. Or you go in and add it up, right? So you'd go add up all of those that were working. So you'd add the management are working, which is 0.325, finance, which is 0.18, and accounting. And so you'd add those up, and if you add those three up, it should add up to the 0.675. All right, and then up top is the accounting major, which out of all of those, all right, so 67.5% are working in their field. 17 are in the accounting, so 0.17 goes up top, right, because it's the accounting we want. And so you take your 0.17 divided by your 0.675 to get to your final answer. And we want probability, so I'm just going to leave the decimal. I'm not going to change it to a percent. So probability is 0.252, and there's my final answer. Alright, so I didn't ask you to try any of these on your own because I wanted to make sure, but there are a bunch of examples that if you go look at the extra practice, they have some there. And I've actually categorized it so you can go look at the tree cases. So the 7.5 tree cases and the 7.6 tree cases are paired together. And so go look at that in the extra practice if you want to study. And then we're done. Alright, so hopefully you're practicing, preparing, and getting ready. There is a load of information for Chapter 7. Chapter 7 is probably the biggest chapter that we do. It's a massive chapter. Again, it's the basic probabilities in the first three sections, the conditional probabilities and independent event in 7.5. And then 7.6 is just conditional, a special case of conditional. So again, 7.6. Alright, so make sure you're studying and getting ready for that. I'm going to stop that there.